So let's take a look at this graphing review 1. That was the homework. Hey, we will have a quiz that will be assigned. And when I say that, that just means that it's going to be on Schoology. And it amazes me how often a student doesn't utilize their resources when something is offered at Schoology when you're able to be at home doing it. Kind of saddens me. It's like, you got a 0 out of 30 on this? Yeah. Oh, yeah. Help each other. Help each other. I'm just telling you, help each other. Okay, deal? Grab the kids that are in the class after this one that are taking like Calculus 277 and see if they'll help you. Okay? All right. Hey, questions about any of the graphing review number 1 that I could help you with? Just to make sure we feel comfortable with it. Number 7, the one that's the x squared plus 3x minus 10 is less than. Okay, so I'm going to go to desmos first. Is that okay? So I think just by trial and error, and me being about a day and a half ahead of you guys on desmos, I think we can go ahead and graph this just exactly as the equation's given. 3x minus 10. And then they said it's less than or equal to 0. Okay, I think it's going to do it for us. Okay, so this is what the graph looks like come desmos. This is not the parabola. Does that make sense? But it does give us the red range is definitely where our answer is going to exist. So we want to show where the value is less than 0. So the entire red bound region is where it's going to be less than or equal to 0. So I have -5 and 2. So for number 7, you can literally just answer it this way: -5 comma 2 square bracket. This is where the whole graph, if I had graphed it using y equals, would basically be the graph is like underneath. That's basically what's taking place. Even though desmos isn't showing that, that's what it's doing. Okay? What else did you see I could help you with? Yeah. Go ahead. 12? Okay. Now, I know there's a couple of numbers that are duplicated because us math folks can't count. All right. Thank you for asking about that. That's a great one. Okay? We can still use desmos to trick it. Okay? So we're going to jump into our buddy. We are going to go to the table first, and we're going to plot the point. Which one? I'm doing 12, right? 12 and -1. Okay? Let me darken that. All right. So far we know that. You feel totally comfortable? And you know the equation y equals mx plus b. Now we're just going to modify y equals mx plus b a little bit. We're going to go y sub 1, and then we're going to use tilde, not double tilde. And rather than have an m, because they gave us the slope already, they told us slope is -2. So I'm not going to use m, I'm going to use -2x plus b. And I have to go 2x1, sorry about that. 2x1 plus b. Okay, so now it has given us the whole equation. So we know that the equation right now has to be y equals -2x, and then notice it gave us the b. So it's y equals -2x plus b is our linear equation that would work. So I'm utilizing desmos with the information I know. I have to use a part of it to make the point, and then I use the second equation to get the other thing. Does that seem okay? Yeah. Go ahead.
Number 8 and 11.
8 and 11. Number 8, I think we can do that whole thing on desmos as well, same way. We're just going to plug it in as is. So I'm going to put this in parentheses, the x squared minus 4. And then divided by, and just to be safe, I'm going to put the bottom in parentheses. I don't know if they're all necessary to have all the parentheses. Just know that when you write it, if it doesn't, Which one?
That's not 8.
Oh, I'm doing the wrong one. Sorry. Oh, I see 8. Okay. All right, so this one I don't necessarily have to use the parentheses because I only have a single term. And then let's see if this will work as is. So I'm going to test it one way, x squared minus 9. So notice that the whole fraction has appeared. So I think that's going to be appropriate. And then I'm going to use the less than or equal to, oops.
And I just wasn't really confused about how you would get your answer because it's -3 and 3, but do you just like skip around that?
Okay. So wow. Okay. So this is what it basically looks like. So I'm going to come out. If I keep coming out, notice the red region on the left keeps going. Like I'm already out to negative 150. Okay. So that's telling me that if I plugged any from negative infinity all the way up to,
-3.
I'd say that's -3, even though it's not showing up. And then from 0 to 3. So, so number 9. So it's going to go from negative infinity, and remember the infinities always have a softer rounded bracket, to -3. And I think this needs to be a rounded bracket here. Now the reason I say it's a rounded bracket there, and this makes sense why desmos didn't work. If I plug that -3 into the denominator as it sits, I'm going to get 0 on the bottom. It's going to be undefined. So that tells me that, watch my arrow. As I come across, any of these numbers are going to work. And as I get really, 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 really close to where that arrow is at -3, I'm like at -3.0000001, like so close to it, but I'm not there. I think that's going to be work. That's why I'm going to use a soft bracket. But then the 0 is going to work just fine. Because if I plug the 0 in, I'd get 0 over 0, 0 over -9, which is 0. So the other part of my problem can be square bracket 0 to 3, and the 3 has to have a soft bracket because, again, if I plug that 3 in, same as the -3, it's going to give me a 0 in the denominator. Okay? Does that make sense, my friends?
Yep.
So again, desmos is being a tool. Now, I just want to clarify, my friends. This right here is not what the graph of this actual function would look like. Okay? Because I only have the x values in it. It shows us the two-dimensional graph of it, but it's only a one-dimensional graph because I only have my x's. I don't have a y. The y classifies a second dimension. Okay? And then you said 11?
11. You get a really funky graph when you put it in desmos.
Yeah, so I would make sure I have the left side as y equals and I have the right side as y equals. Okay, so I would create two equations. So the left side is this, x squared minus 3x. Okay, so it's just a parabola. That's nice. That's simple. And then I'm going to make this one. I'm going to go y equals, and I have a negative, and I could try and find absolute value, or I could type ABS. Now notice when I'm typing it in, see the A and the B are kind of italicized. As soon as I type the S, they become upright. That means it knows it's an absolute value. So I don't need the absolute value. I just need to group it. So there's my x minus 2. I'm not worrying about them being absolute value signs because I already said absolute value of this quantity, and then plus 3.
And then would you just go with where the numbers intersect?
Yep,
Or?
it's where they intersect the graph. So I'd give the answer as negative 2.36, just the x component, and 3.449. Okay, that's all the answer would be. Okay, I don't use the y component. The reason I don't use the y component is my original equation does not have y as part of it. So I'm not looking for the point. I'm looking for the intersection x value only. Any others on that particular assignment that kind of got goofy, out of control? Content? All right. Important thing now. So coming this Friday, it's another real life. I am going to do fair division. Okay? And I have a pretty good idea of how to use fair division, but I'll pose you guys a question that you do not need to answer now. I just want you to ponder it, so stick it on the back burner. If you and your friend go to your house and there's a piece of cake and there's only one piece of cake left, still following me in this situation?
Yep.
And it's a good sized piece of cake. It's not like, when my wife says, here's your piece of cake, and I look at her going, what, are you mad at me? No, it's a nice, good sized piece of cake. Like, one person eating it is ridiculous. Two people, you're still getting way more calories than you probably need in the whole day. But there's that piece of cake sitting on the counter, and there's a note that says, please finish the cake. Still with me?
Mm-hmm.
But your friend saw the note, so your friend knows that this cake is available for them. You still following? How would you divide that piece of cake to be the most equal two pieces ever? Now, I don't need you to answer now, but I just kind of want you to think about how you could slice that piece of cake that would be fair for both of you. Okay? So that's something that's kind of where we're heading on Friday. That's kind of what we're going to start with. But I just wanted to plant that seed of, think of and I don't care if you like cake or not, take your favorite whatever, and it's your friend's favorite whatever, and you need to cut it into two equal pieces. How can you guarantee each person is getting a truly fair share of that cake? And giving it to the dog is not an option. The dog's going, hey, what about me? Right? You guys know the pup? All right. How do you feel? You feel all right? Fair division. Hey, so let's, are you all feeling pretty good about this desmos thing? You're realizing that when they give you the window, that window is really only when you're using the Texas Instrument graphing calculator. It doesn't apply to desmos. The reason it doesn't apply to desmos is if I had graphed this on a graphing calculator, I have to zoom in, zoom out, change the window. Well, this just allows me to zoom in and zoom out and keeps the graph there. The TI calculator, there's times that you might be out in Never Land and it's taking you forever to figure out where the heck it really exists. Okay? Couple of rules of thumb. When you have an x equation equals another x equation, and this could be anything, so I just give a hypothetical, like let's say you had the third root of x plus 7 is equal to the absolute value of x minus 3. Okay, if you had something like this, you set each of these equal to y, so y equals, and this is also y equals. And then you find just the x part of intersecting point. Does that make sense? Everyone's happy? Everyone's day is good? I'm a little bit upset. Y'all know where my sense of humor is, right? If someone slips and falls, what do? Point and laugh. My wife sends the text this morning. She's a professor at University of Colorado, Denver, teaches chemistry for engineers. She sends me a text. I totally just fell on my 3-letter word, starts with an A, ends with an S. There's a second S that's in between the two. And so I sent a text back going, was anyone there to watch so they could laugh? And so she called me a certain type of hole. But you guys figure out which kind that is. So Stuart might have to sleep here at school tonight. Sorry. So if I'm wearing the same outfit, you guys know what happened. Like, Stuart, you couldn't go home, huh? No, I didn't make it. So, Yeah, needless to say, I think I have a pretty good rapport with my wife. She understands I have a bad sense of humor, especially at the grocery stores, because she won't let me go anymore. So let's work on the graphing review. Number 2, giving you guys a nice amount of opportunity to deal with it. I figured y'all did last night's homework, so you're all good. But if you have any other homeworks that I missed, are any of you still missing the test, the quiz? I can't even remember. Who owes me?
I don't know who owes me.
No, you guys are all caught up. Thank you. Appreciate y'all. But so does that make sense that the next quiz that's coming will be on Schoology? I'll give you like 5 days to get it complete. Okay? If I'm giving you something on Schoology that you have 5 days to complete, that's an assessment that you can do at home. Who can work with you on it? Anybody you want. It's like, sweet. My dad has a degree in math. He's going to do it for me. Okay. And then your dad's going to get mad saying, why did I miss number 3? Life happens. You guys know what to work on? And again, if you have anything to show me, let me know what I need to know.